Yeah, so contact details there and everything. So I'd like by a show of hands, how many of you work in a startup? And keep your hands up. How many of you are contemplating joining a startup or starting one? All of you, yeah. I'm so sorry for you. I'm so sorry. Because these are the facts. And you can do these measurements a number of different ways. The numbers just don't look good when you're a startup. So you need to figure out how you're going to run about it and how you're going to avoid it. So looking at those who fail, that could be an exercise of pain and tears and blood and sweat. So we will avoid that, but there'll still be pain, tears and blood and sweat there for the other 10%. But we're going to look at what makes them succeed, because that's what we want ultimately there. So, and this is also from this Forbes thing, that if you have a product that's perfect for the market, that's a good sign of having a success. There. You don't ignore anything. You don't let anything slip by. You don't let regulations or other things. You're on top of everything. Already here, you can break a sweat now if you want to consider doing these things. But these are the things that works for these. You get a company that actually grows fast. If you're just lingering, you're probably going to end up in the 90% there. And then the last thing from this report that actually falls into my pet peeves here is the team you have there knows how to recover. Because you're going to take a beating over and over again. You're going to make mistakes all over the place. So you need to learn how to recover from that. So the core message here is you need to be evolving your startup, and you need to be building your entire app and startup with failures. Don't ignore that. Embrace that. And here's an example where this actually follows the curve of what Draw Something had, where they had a number of users over time. It was going fine, just working their way up. Then they had a huge success spike. And the trajectory was like this. And everybody that had put money into it was like, yeah, it's coming out. But then this happened. Boom. The thing didn't scale. And we all know that Draw Something ended up as a success. But when they ended up in this situation, they switched to Couchbase, an Erlang-powered technology. So this is what you want. You want Erlang to be behind you as a startup there. And if you need to do a little bit of research and also think about how you want to do it. So this is a good book. There, it's more operational than some of the other ones. So I like that one because you can then just go apply things and take it from there. Notice the title subtitle there, iterate from plan A to a plan that works. That implies you don't know where you're ending. So you need to be ready to iterate all the time. And the way you want to do this is, you want to do experiments to figure out what works. There, you'll run around having a hypothesis about something, and you want to go prove or disprove that hypothesis. It doesn't help saying, I think the users will like this, and then you just build it. No, you need to do it a little more intelligent than that there. And then they talk about this, the pivot. This is where you change direction. Not on the whim of something, but because some of your experiments showed that you need to do something different to be successful. And in total, what is it that they're asking you for? Clues? They're asking you to fail fast. Because it's the failing that gives you the learning. Just doing everything and not getting anything out there, no. You need to get things out there and make them fail. And it has to happen relatively fast, otherwise you'll end up in 90% graveyards of startups. So that means you need to embrace failure. And as a culture and as humans, failure is something that we often feel stigmatizes us. We have to drop that. If you are afraid of failure, don't do startups. You need to learn how to enjoy that. It takes time, but you'll get there. So how do you go from zero to actually making a ton of money? And you can substitute whatever currency you want, just as long as it makes you happy there. So the first stage is you need to figure out if the problem you're looking at and the solution you want to provide has a fit. And this doesn't mean that you have to build anything. This means that you go out and test the waters by talking to people and say, oh, I know there's this problem over here. I'm thinking about solving it in this way. Will that work for you? That's the kind of feedback you need, and this is a cheap way of getting it. Don't build everything in 9 months in a silo. Go out there and get some cheap feedback there. Then the next thing you want to look at, then you want to make sure that this problem has a fit with the market, because otherwise you might have a solution, but there's no market for it. So you need to make sure that there's a fit there too. And there are also ways of doing that without having to build everything out. You can take these there. And then finally, because we want to make money at the end, at least enough to survive, so you need to scale it somehow. And the focus in the first 2 stages, it's the same focus you have there. You have a focus on validated learning and pivots. So here you're really talking about, I need to fail so that I can find the next thing that will bring me closer to what works. This is how you want to work. And then at stage 3, here, the focus changes because now you have a fit with the market. You know that you're on the right track. Now you just have to scale it there. So now it's growth and optimizations you're looking for. So any experiment you're doing now is an optimization there. So that's how it changes. And here's big danger zone, because normally you'll end up asking for money somewhere to do this. And normally you end up asking for money between stage 1 and 2. And what does anybody that tucks money at you, what do they want? Interest, yes. They want money back. So they are already thinking about growth. So there's a mismatch there. So you need to be really careful in that phase, because you're running around making failures all the time. I need to pivot to figure out what I want to do. And you have an investor going there, well, no. You need to scale so I can get my money back. So be careful in that zone there. And some of the things that can go into this, and this is where everybody that's doing that, have my favorite technology for something, they talk about development speed. And let's be honest, most development stacks today, they have decent speed when you're trying to develop and put something together. There might be some quirks somewhere and everywhere, but it's pretty good, unless you choose to do everything in assembly language. But that's a different thing. So this is not going to be our primary concern. So we're going to focus on the experiments. So the thing is, you want to try new things all the time, so you can fail and learn from it there. At the same time, you want to keep the system running, so the things that are actually working and might be bringing in money are not being taken down by your weird experiments. And if you have a coder like me in the company, you really need protection, because I write shit code and I make things break all the time. I then think I can fix it fairly quickly, but that's just my delusions of grandeur. But that's a different thing. So for this, you need supervisors. So that means that the Erlang system already has something that supports you in going out on doing these wild things, which is awesome. Makes you sweat less. And then when we talk about the pivots there, so then it means that whatever you've done in terms of code-wise, it needs to be able to be changed easily when you figure out that you're on the wrong track, or at least reuse parts of it. So the things that plays into this in the ecosystem we are in is we have functional programming going for us. We have NoSQL there. We have protocols. And then we have, of course, I can't do a slide deck without the golden trinity of Erlang. So that's the fail fast, share nothing, and failure handling. So over the next slides, I'll be going through how all these different pieces have a role to play in how to make your startup successful in failing fast, getting to the money there. And just so that it's not just lean startup guys that gets the credit for this, or I come up with something here, this is what Edison said, and he's long gone. I have not failed, I've just found 10,000 ways that won't work. It's the same attitude you need to take and bring into these things. Expect to fail, but expect to learn from it. That's how we grow. And then, of course, on a more draconian style, is that all failures, they are created equal, but some are more equal than others. So let's go into that. So there are things called good failures in this setup. So that is a failure that leads you to insight about your business, about what makes money. That's a good failure, because then you're one step closer to the thing that works. So everything in these things, every tiny thing that brings you closer to a business model that makes your bank account have black digits at the end of the month is a good thing. So these failures we welcome, because they've taken us off the track down to something that doesn't make money. So this is the key point here. Then we have the bad failures. And they're really bad, 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 bad. We want to avoid these. So downtime due to bad quality software means, again, consider if you want to hire me because I write bad software. So let's stay out of that there. And then you don't want to make any choice that limits your ability to learn from the business failures. If you've taken a tech choice that then makes it difficult for you to do the pivot and take the learnings that are really bringing you closer to the money, then you've done a really poor tech choice. So for all of these things about understanding the market and everything, you also need to have people that are competent on the tech side to make sure you make the right decisions and stay loose there. And then people have been talking about these different things for a long time. So Fred Brooks wrote this wonderful book about the silver bullet. How many of you read that? This is way too little. Go get that one. It's really amazing. I think it's 30 years old or something like that now, but you still have to read it there. So he talks about two types of complexity. There's the essential complexity, that's solving the problem. There's just things you need to solve to get anywhere. So that's the complexity you're born with, and you can't get any easier than that. And then there's the accidental complexity. That's the stuff you put in by making poor choices. And that one, you must minimize it. If you don't minimize that and just run around like a headless chicken, or rather a headless goose, because that's more dramatic, there, you're gonna kill yourself slowly but surely. So this is one where you need to be really, really aggressive about avoiding this. Accidental complexity is bad, and it's one that you cause yourself. So there's nobody to blame. There's no crying in the bank, oh, I chose the wrong technology stack. Yeah, you chose had to make that choice, so don't go there. So, and then when it comes down to this with complexity, you also changeability. So 80% of the lifetime of your software is spent in maintenance. And that even also applies in when you're doing a startup, because you have to look at your code. Most of the code, you've written it, and you have to do one of those pivots. So you need to be able to take the code and understand it and see what you can reuse there. So make it easy to change. And then, in terms of making things easier to change, in most of these things, you need a data model, how to handle your data. And this, be slightly mathematical about this. Your first data model is wrong. Your second data model is wrong. And since I've studied math, I can now apply induction. All data models are wrong. Which means that if you buy yourself into something that's fixed forever on a data model side, you're dead. So therefore, you need NoSQL. Because the flexibility you get from having not all these schemas and fixed framework around you allows you to have that the velocity of your development drops slower. I'm not promising you by choosing NoSQL that the velocity doesn't drop. Velocity always drops. The first line of code is always the most easy one to get in. It gets more difficult time, but let's try to make things so we don't drop too fast. And you should not use schemas. Please, don't do this. Yeah, don't do this. Because you have, well, you can do it if your middle name is schema and your last name is von Upgrade. If you run around saying that, by the way, I'm Torben Schema von Upgrade, then it's okay. Use schemas, because then you know what it is. You dream it, you live it there. Point here is, spend your time on the features, not on schemas. So that means NoSQL. And then, since I come from a company that does a NoSQL database, how does RiakKV fit into this picture? Because then, basically, before you scale, everything runs on one machine. If you think you have a business model that from day one needs 10 or 20 machines, you're doing something wrong. The scaling part is a rich man's problem. You need to get the first paying customers before you go anywhere. So, can you do RiakKV on one node? Yeah, you can, but it's not optimal. Because Riak is meant to have this fall-over thing with other nodes taking data and everything there. But you'll get benefits on availability when you do scale. But then, oh, wait a minute. Scale, we're not there yet. So how does this fit in? So what you have to do, you need to use the DAL to give you freedom. Does everybody know what the DAL is? No. Yeah. Data abstraction layer. I'll have a sticker for you. I'll find a sticker for you. That's good. Exactly. It's the data abstraction layer. You want at all costs to abstract the way how you're storing data. This is software engineering 101. It's not even startup 101. Hide the way. Don't let the database leak into the rest of your code base. Because one day you're going to get fed up with React and you want to put something else in. No, that won't happen. You'll get fed up with Cassandra after 4 hours and then you want to switch there. So what you can do in the meantime is to make sure you have the data abstraction layer in place and then you do the NoSQL with Amnesia. Very simple record. It has 2 fields, a key and a value, and you stuff whatever you want into value. Because normally Amnesia has the structure and everything. You just use 2 fields and you can stuff whatever. And the important part here is, the really important part here is, you get used to having a key value thing, the way you approach your data, and that means the moment you're ready to scale, and when you're ready to pay us money for React licenses and all that fun stuff and support, you just switched in React and you don't have to change anything above your data abstraction layer. And you have to do that anyway, even if you go with Cassandra. We won't be friends anymore, but anyway, so just remember this, but you can start with Amnesia, and Amnesia runs beautiful for these things there. And if you don't know how to use that, take a class with Francesco, and you'll know how to do it there. Then some of the things from the golden trinity of Erlang, share nothing. That is super, because that means that only one thing breaks when something is wrong in your code. You're doing an experiment, and there's one thing that falls over. And you're just smiling. Yeah, I'm getting the feedback I need there, and no more. And then another thing on failures, because when you have these systems, the likelihood of a big system like this, now we're a little further down the road, but anyway, so this won't work. Programming errors, because some of you hired me, so I'll put errors into your code. Sorry, that's what I do for a living there. You have disk failures and you have network failures. Those are not my fault, I promise you. That's not me. But they will happen to you all the time. Anyway, so that means you can't ignore failures. That's just going to lead to an epic failure on your behalf that, you can't get around these things. And the way we notice these things, and that's why we have Murphy's Law, anything that can go wrong will go wrong. And that's slightly pessimistic, but you need to live with this. And they also say that this probably came from whatever can happen will happen. But I'll promise you this. You won't get super nice things happening by accident. You need to work hard for it. If you get accidental goodness just dumping out of the typing you're doing, all the better for you. But don't bank on it there. And then we can say that if you want to do something with fault intolerance in mind there, you just take whatever programming paradigm that's out there. Those are mostly fault intolerant. That's also what we had at the fireside chat yesterday, that Erlang is just mentally different, on a different planet. And that means in these situations, you need to deal with all errors or you have to die. And it's the entire thing. It's in your entire website or your entire thing. It's just gone when you have one error, which you don't like. Because then you end up, maybe you end up looking like Dustin Hoffman there, but you end up having to protect yourself and going around doing defensive programming all the time. You need to fight it all the time. And this is the Outbreak movie. I never understood why they made the general. You remember there's a general in Outbreak? They have this thing where the disease is spreading and everything. And then the general comes in and he's an Erlanger. He's a true Erlanger. He just say, let's nuke it. Let's fail fast. Get rid of the disease. There. And for some strange reason, the first Erlanger in a movie is portrayed as a bad guy. I don't get it. Yeah, there you go. So then fault tolerance, and that's Erlang Elixir. Fault tolerant by design, which means that you can say this wonderful, failures are embraced and managed. So this feels really good when you can say that. On the movie front, this is of course Bruce Willis in Die Hard, because he's just having a ball there, and he'll get up. Whenever he fails, he'll just get up. There. That's the benefit of having a supervisor or machine gun, depending on the situation there. And then, just to prove that this is not just fantasy stuff there, we can go back to Jan Henry's study he did for Motorola back in the day when I worked there. So he had, we have to have the numbers up here. So he rewrote a C++ application Yes, granted, that's not a fair comparison. C++, horrible, all that shit. But anyway, it was written by really good engineers, so maybe it's not the best thing. So the application code that solves the problem. Remember, this is about making something that makes your end user happy, so they'll pay you money. The code that solves the problem, this is the app code. And you can see here in the C++ thing, yeah, these two things, it's less than 20% of the code that is addressing what you're trying to make money off. The rest is just all that mumbo jumbo you need to do in other languages. Memory management, defensive programming, what have you. You don't want that. You want the Erlang experience, where you have over 60% of the code addressing the needs of your customer. What's going to bring you money? This is what you want there. And we can thank the founders of Erlang for this thing. So you had 3x with Erlang. And that means in this, just embrace the failure. Embrace this so you can get into this mode of focusing on generating lines of code that makes you money. That's how it works. And then another thing you could do, and twist it slightly because failure seems to be important somehow. If you can wrap failure so that others can proceed without dealing with those failures, you might have a product. So it's a proxy thing. So there might be a business in there. And that's actually Riak. So you have this huge amount of machines, you're running Riak on it and everything. The disks will have failures, and the network will have failures. Look how I've removed software errors or programming errors. It's because others have coded most of Riak, so I can't take down the system with my coding yet. There, we'll get to that. And then the solution here that Riak puts in to deal with all these failures and wrapping failures in something that's a product you can sell, we replicate data to counter that nodes are failing in our system. So we have this normally 3 nodes that we replicate to, so you can have 2 nodes failing and the last one will still have your data, so that's good. And then you detect those and you provide substitutes, so you keep writing to 3 nodes all the time. Again, we're wrapping failures from the end user to make sure that he can survive. There. And then after that you have the handoff where you return the data to the rightful owner, so everything is structured well again. And then we also have active anti-entropy where you do repairs after failure. And on top of this, if a specific message has gone lost or something there, you get these things. So this is where we try to wrap failure and then package it up and sell it as a product. And it works. We're making money. So that's good. At least people are paying us money, so let's put it like that. So the thing we're looking into is that here we're sitting here, this is software development, you have your entire team there sitting there and enjoying whatever design meeting they're having right there. And the guy at the far end of the beam there, the one that's the first to fall off if somebody starts pushing out there, that's the product owner. Because this is like football or any team sport. You don't fire the manager if you're losing. No, well, no, shit, you do fire the manager. Yes, okay, which means I'm at top of engineering and Basher. Shit, okay, that was a scary thought there. No, but you do fire the manager all the time. You don't fire the team in the middle of the season. You don't yank out the entire team and put a new team in and tell the manager, you're doing great, let's continue. No, it's the guy in charge that gets fired. So if any of you are product owners, be scared. You're the first to be decapitated when shit hits the fan. So business benefits here, and this is where you as a product owner should start smiling. You have only one process that dies, which means that continuous service of everything else. It's not like your entire thing is down. So that's one thing from this wonderful thing Erlang OTP gives you there. And then if you have a corner case, it doesn't happen all the time. You could fix it when you feel like it, when there's a return on investment on it. Yeah, listen to that. That's the kind of boardroom talk you can do when you have Erlang backing you there, because you are in charge. You fix it when the cost to fix it outweighs the cost of just having it and do manual fixes. You are in charge now there, and that's not the software being in charge. That's what you want if you're leading anything or running a company. You want to be in charge. You don't want to let the code you've written control you. That's the bad thing for you there. So actually here, now we can have a total drum roll of buzzwords and everything. You have a software architecture that supports iterative development. And they can come with everything else they have, but they can't come in and compete on this one. The Nordic JS guys over there, forget about it. They don't have an architecture that supports this. So we're spot on with this. Yeah. And then I've been told that I normally yell at people every time I have a conference, go on stage. So I'll try to control myself now there and just say this very gently. Very, very gently. It doesn't make it any less serious, but be very gentle now. Say, this is not a warning. It's a threat. And I'll explain to you what the threat is about. Yeah. We want clean APIs. You put one module in front of an app and make sure that all access goes through API calls in that module, and even inside the app, you have an API for each little thing you're having, and you're using that API to talk to it. Period. And then you might go, oh, wait a minute. Some of you are, oh, maybe, not, yeah. And then I say, oh, if I have a PID, can't I just bang it a message? Like, boom, it's got a message. That's Erlang's good for message passing and everything. And I'll say, no, please don't. Notice, I'm not yelling at you. I'm not yelling at you. So next thing is, I know it's a gen server. Can't I just gen server call it and just do that because I know the PID and everything? How do you want to die? I'll make sure, and this is the threat and the promise and everything in it here. Somebody will get medieval on you if you do these things. Maybe not me, but somebody else will. And then the warning will be here, and you will remember this. I can read it for those who can't read it. It's your own fault. What did Le Hoff tell you about sending messages without using a module API? That's the threat here. I've not yelled at anything. I've just laid it out nicely, and maybe I should work on the way I present this, but really, really don't do this. You're going to kill your startup, or you're going to kill the next person that starts looking at your code, which in all honesty might be yourself. Don't do this, please. Please, you'll make me cry. So, so how do we solve these things then and put some other things in there so we actually stay disciplined about this? Because this is also about discipline. So that's where you need to go to look at protocols. And I'm not talking about big, fat, hairy protocols in big documents and telecom standards and everything. Been there, done that, got the scars and all that fun stuff there. No, a protocol is basically how do things solve a problem together. You need to make your components work together in a nice way. So you need to focus on that. And the thing is, you can then come in to do what I call ostrich development. You can document these protocols that are in your system or not. They're still there. So the question is, do you want to run around coding like this and looking slightly stupid and just waiting for some of these accidental complexity things to hit you, or do you want to be in control? So you need to get them in early. And then another trick here is, if you make a design error and you're talking about design, it's cheaper than changing code. Simply is. Changing a little diagram should be cheaper than changing code. If not, find a different editor to do your drawings in. Yeah. And what you need to do to document these protocols is you need to have an interaction diagram that tells you something about which types of messages are being sent between the different processes in your system. And you need a message sequence chart that shows how the flow of messages are between the different components. And you can try, again, be my guest. Try to live without this. This is still happening in your program. Either you make it explicit and you talk about it and you manage, or you ignore it and run around like an ostrich and try to make software that works. It's not going to work in the long run. And that also means that when you try and do these things, there's some hints about it. You should limit the logic that goes into a single process, because you can avoid all these message sequence charts by shuffling everything into a process. Don't do that. Try and make small, simple things and then leave complicated orchestration of things to others. And I have an example here. How many of you know this board game, Acquire? That's one. Again, it's too few. It's the ultimate capitalistic game. You're just trying to make more money than the rest of the people by outsmarting them. Come on, go get it. Anyway, read about it on the net. So the idea here is that you buy stocks in companies and you place things on the board tiles that make the companies grow. And then you want to buy, of course, when the company is small, and then sell again when the company is bigger. So that's the idea in the game. And then you want to go and let's have a look at this MSC for buying stocks here. There. So we have a turn process here. Can you see my pointer here? No, you can't. So I'll just jump down here and do a little bit of pointing. Yeah. So the turn process here, it's asking the player which corporations do you want to buy stocks in. It's giving a list of corporations to choose from, and you come back with a list of choices of the stocks you want to buy. And then for all of the different corporations, you go in, you do a reserve to the bank. Say, I want to reserve this particular stock for buying, and he go, okay, the price will be this, and here's a reference so we know what we're talking about. So this is a certificate for this stock there. Then the next thing is, then you want to debit your own bank account with the price of this stock, and we get an okay back because we have enough money to do it. This is just a success case. And then you say, you give a buy on the reference back to the bank, you get an okay back, and then you add the stock you just bought to your portfolio. And then you repeat until you're done, and then the turn will send the buy result back to the player with everything there. Do you like that design? Oh, it's good, good. I made the design, so you shouldn't like it. It's horrible. This is way too complicated there. But this is the first thing I came up with. And I hadn't written a line of code. Apart from code being more expensive to change, there's also the mental thing. If you've written some code, oh, I don't want to change it. It's my code. Yeah, that's also a thing you need to let go of, by the way. So you can simplify this. So in the loop, instead here, we have a way simpler way of doing it. You're just telling the bank, I want to buy a stock in this corporation. And the bank takes care of asking the account if there's enough money, getting okay back, adding it to the portfolio, and say okay price back. And then you can also have the error handling in here quite easily. This is a lot easier there. And it didn't come around to me the first time. It rarely does, because these things can be tricky. And some of the ideas that goes into this, and also there is some from the book, Clean Code. And I think, had I read it back then, before I started these things and had to iterate my way through this and finding the right protocol for this and get it out, then this temporal nature of the first design, that would have been avoided. I'm very, very confident that I would have avoided that error in the first place. Or maybe not. Just accept that you'll do these mistakes, but find a way to do it before it becomes expensive. Then we want to put all of this together. So we have all these different tricks of how good things in the Erlang system and everything can work for us, and the techniques to put into it. So how do we put it together? Well, stateful is the new black. So if you're running a website that has no state in it, then don't do it in Erlang. Don't do it in Elixir. Stay doing it in whatever other thing. Just don't bother coming here. But you need stateful things, and that's also where the money is. So the architecture for this is, you throw in something to get a good endpoint there, Phoenix, Cowboy, depending on where you are in the world. Then you have your cool app, because it's cool, because it's going to make you money. Then you have your data abstraction layer, and then you put in RiakKV, Amnesia, depending on how far along you are in your scaling. Remember, scaling is a rich man's problem, so you might want to consider starting with Amnesia in the NoSQL trick mode that I had, because then you're ready to throw in React later. And on top of it, you can throw in Elm or whatever your other things are. This is the super fancy stack. If you want to go with this, you can do anything else. But the other things is what we have in our ecosystem that will support us in iterating fast forward and getting all of these benefits I've talked about earlier. So failures here, embrace them, learn from them. You need to go through these stages. They're first, without writing any code, figure out if you have a problem and solution fit, work it a bit, get a little thing going, see if you have a problem market fit, and in all of this, fail, 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 so you can do the pivots and get closer to what's really making money there. And then later on, growth optimizations, a lot of money. You sent me a thank you card at Christmas and everything for following this guide, so everybody's good there. And then you use the techniques we have here, the golden trinity of Erlang, with fail fast, share nothing, failure handling. You have the functional programming, you have the protocols, and you have the NoSQL. Remember these things and go back to these things, and you can always come and ask me for an advice on some of how these things should be done there. And then, above all else, try to make the good failures. Do not make the bad failures. Do not choose Cassandra. Choose Riak. Yeah, no, okay, that's a different thing. Yeah, but anyway, make the good failures because that's how you're going to end up with the money in the end. And that was it. We're hiring, by the way. There, go see our stand, talk to them, figure that out, and also you can still try this Elixir set out there. So that's it. Thank you. Questions? Did I scare everybody away from doing a startup? No, not quite.
How many startups have you done?
Me? Well, I've done nothing on that front there. This is part of the things where you work with companies, and when we worked at the Erlang Solutions, and trying to help them steer them in the right direction and making them take their tech choices there. So I'm just a parrot here on these things there. I just know how to fit these things in when you have a problem of a client. When we went out to them, we've tried, at least I tried, to do these things for these difficult cases with customers and say, no, you need to do these things in this order to succeed. And yeah, some of it has worked, some of it hasn't. I'll protect the innocent. I will not protect myself in this. Some of the advice that was given turned out to not to be okay. But a lot of it actually following this was good there.
Torben, could you explain us a particular situation or a case where a startup chose wrong technology and then they failed fast and chose the right technology? Do you have any use case or a case study or something like that? Can you explain such a case study?
Yeah, that's the best case there is draw something. Because they were on a non-Erlang based technology. That's the first sign of you're doing something wrong there. And they were failing, and then they switched to something that was able to do the thing. But they had all the metrics in place, they had all the feedback, so you can see that now we're failing. We need to do something about it. And then they switched really fast, because it was not too far along for them to do something about it.
What are those metrics?
Well, those metrics are how many users are having too long response times, how many are being totally denied, and how many leave your site very fast because it's not working. So that's the kind of metrics you need to put in place under the hood, so you can see these things. But that's, if you take the book like Running Lean, there's a number of different things you could be measuring on to see if you're still succeeding or if people are starting to run away from you instead of staying with you. Yeah, so that's the whole metric part. I haven't talked about that, but that's something you need to hook into this so you can see when you're failing. That's also when you're doing any experiment here, you need to have a measurement on it. You can't just do a blind experiment and go, that looks kind of nice. No, you need to come up with a hypothesis that you can falsify by collecting some data. That's how you work these things. Otherwise, you're just going to end up with, well, feely, and then you'll be off on the wrong track.
You have been talking about Erlang and Elixir or the Beam-based ecosystem. So what's your opinion about akka, the Scala-based framework for,
Scala, akka?
Akka, yeah. Would you recommend a startup to use Scala, akka?
Sorry. Scala, akka. So, there. It's just a prolonged way of dying because Scala and akka, they're so complicated in themselves. The only thing that can warrant using them is if you're really familiar with them and you have a problem where it's mandatory for you to be on the JVM. Other than that, and if you're starting up from scratch, please don't go there. It's so mentally taxing on you to do the complex stuff that is in Scala and akka. The concepts are way simpler in Erlang and Elixir. So you're just going to bury yourself by unnecessary complexity by choosing a technology that just raises the accidental complexity. Simply. My head hurts every time I read Scala code. It's just too... Sorry.
Thanks for the answers, Torben.
Yeah.
Hey, Torben. So you talked about if you have all this complexity built into your calls by sending messages directly into the innards of your application. What advice would you give to folks that want to slowly unwind that and build better APIs like you're recommending? I'm asking for a friend.
Okay, Tony, thanks for asking for your friend. You can tell your friend that you work it message by message. You take the first message and say, I'm sending this, it's bad. Wrap it in an API call and take that and factor it all through and then take the next one. Just do it slice by slice and get back to the right track. And then you'll feel this stretcher here being less and less, because every time you remove one of them, you'll get back to your normal height there. So that's message by message to do these things. It's the only way you can work, because otherwise you're going to die in refactoring everything in one go. And that's what scares a lot of people, because when you come in and you tell them, dude, this is utterly bad, you need to fix this, and they think, I have to fix everything. No. Do it one message at a time there. And then every time you fix one, you can also slap yourself there, so you don't do it again. That's called negative feedback. So, yeah, good.
All right, give it up once again for Torben Hoffmann.
Thank
you
you.
very much indeed.